Alright, problem number 3, same type. We have 6w plus 3 equals 6, and then open parentheses, this is times the quantity w plus 5, close parentheses, minus 33. Okay, so left side, nothing to do, so we're going to simplify the right side. So I'm going to bring down the 6w plus 3 equals, I'm going to distribute, so this is going to give me 6w, 6 times 5 is going to give us 30, and then bring down minus 33. Alright, and then we're going to simplify like terms on this side, the 30 and the 33. So 6w plus 3 equals 6w, and this is going to give us a minus 3. Alright, so here again I'm going to combine and move my variables together. So I'm going to subtract 6w from both sides, and that goes away, and then I just have 3 equals negative 3. Okay, so I could move the 3's and have one side equal 0, but it's irrelevant, it doesn't matter. When we lose our variables and I'm left with something like this, now like the last problem, unlike the last problem, this statement is false. Okay, so before we had 0 equals 0, and even if I kept going, if I added 3 to both sides, which I can do that, just to cancel out 1, this would be 0, and this would be 6. 6 equals 0 is still false. Okay, so when you get a false statement, that means this problem has no solution. Okay, no solution, or you can do just like 0 with a line through it, or O with a line through it. So there's two special cases. If your variable cancels out, so whatever letter you had to begin with, it completely gets canceled out, and the numbers you left with give you a false statement, it's no solution. If it gives you a true statement, it's all real or infinite solutions. So in this case, we get no solution. And number 4. We have some fractions here. We have 6z minus 4 over 4. And then we have plus 9 divided by 8. And that is equal to 12z plus 1 divided by 8. So 12z plus 1 all over 8. Okay. In order, the best way to solve these fractions is to get rid of the fractions. That's what most people don't like when they see this problem. So, the opposite of division is multiplication. So we want to get rid of these fractions, we need to multiply by something. And we're going to multiply by the least common denominator. So out of these numbers, we have different 4 and 8. Okay, so the least common multiple of 4 and 8, there's a couple ways you can think about doing this, so I'm going to give you a little short review. You can take the 4 and the 8, those are the only different numbers that appear. And we can break them down to primes. 2 times 2, and 8 will be 2 times 4, and then 4 will break down to 2 times 2. So this in primes is 2 2's, so 2 squared, or just 2 times 2. And then this broken down to primes, we have 3 2's, 2 times 2 times 2. Alright, the least common multiple, or 2 cubed, let me write it like that. So the least common multiple, when you break it down to primes, you look at each of the base numbers, so the 2's, that's the only number that it shows. You write that down, and you would take the highest exponent, which would be 3. So it's like if you had kids and you want them all to have the same thing, This one had 3 2's. This one only had 2. You would need to give this guy another 2. And at the end of the day, 2 times 2 times 2 is 8. So 8 is your LCM. Now the old method to find the LCM is just to list those numbers and then start multiplying. 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, and you just go on and on and on. Same thing with 8. 8 times 1 is 8, 8 times 2 is 16, so forth and so on. And the first number that they both have in common is 8. That's the least that they have in common when you multiply. Least common multiple, that's where that comes from. So 8 is the least common multiple. The whole reason for finding this is we're going to multiply everything by 8, or both sides by 8. And when I say multiply, I really mean we're going to do a multiplication / division to get rid of that 8. So here's what I mean. We're going to multiply the left side of this fraction by 8, and we're going to multiply the right side, of this equation by 8. So whatever you do to one side, you do to the other. So this means I'm distributing 8 here. The way you multiply fractions, number times a fraction, is top times top, bottom times bottom. So 8 is really 8 divided by 1. So 8 is multiplying on the top, not the bottom. Okay. But what I really do is I'm canceling out, or I'm dividing. So here's what's happening. 8 is going to react with this division by 4. So we're dividing by 4, but we're multiplying by 8. So 8 divided by 4, that's what I'm doing, is going to give us 2. So what I'm really doing is 8 and 4 are going to cancel out to give me a 2. So I have a 2 here. That 2 is going to multiply this problem, 6z minus 4. Alright, and then when I multiply this 8, because you got to do both terms, you're distributing 8 over here. This 8 is going to cancel out with division by 8, and it's going to leave me with the 9. That's the whole reason why I picked 8, or why we found 8. So look, no more fraction. This is what I have now. And then on this side, this 8 is going to react with division by 8 and going to cancel out. And we're going to be left with 12z plus 1. Okay, so it'll take some time and practice if you're not familiar with that. But if you want this problem to be a lot nicer and easier to work, you're going to get rid of those fractions by multiplying by the least common denominator. Okay, so once you do that, we have a basic regular problem that we've been doing the whole time. We're going to multiply by 2. So again, where did this 2 come from? 8 divided by 4. And the 8, we multiplied both sides by 8 because it was the least common multiple. So 2 times 6z, 12z. 2 times the 4 is 8, but it's going to be a negative. So minus 8 plus 9 equals 12z plus 1. Over here, we're going to distribute, or sorry, not distribute, but combine like terms. It's going to give us 12z plus 1. And then over here, we have 12z plus 1. So remember that scenario when both sides were exactly the same? That's when everything canceled out to be 0 and it was all real numbers. So anytime you get to this point and you see that both sides are exactly the same, you can stop and you will know that your answer is all real numbers because both sides are exactly the same. So if you don't remember, go back and look at video 2. That was the second problem we did. So infinite solutions, all real numbers.